Why is one of your freeze dryers taking twice as long to do the same product? You loaded them both up with the same product. One takes 36 hours, the other one takes 48, another one takes 72 hours. So did you do something wrong? Hey, I'm Gene. Welcome back to my channel where I answer freeze drying questions for people all over the world. So, do your freeze dryers have personalities? What's causing these problems? What's causing the difference? And if there is something, how do you fix it? And by the way, do all freeze dryers act this way? By the end of this episode, these questions and more will all be covered. So, what is it that causes people to say, hey, my machines, I'm pretty sure each one has its own personality? Well, there's actually pretty good reasons for that. Machines don't actually have personalities. The whole point of it being a machine is that it's supposed to be repeatable, right? You're supposed to be able to program it and get a consistent response. So, and when people say they're sure their machine has different personalities, they're usually talking about cycle times. They run the same product in the same quantities, and this machine gets, the product done much quicker than this machine. So what's going on here? Why do you have something like that happening? So first off, let's just start by saying that this is almost exclusively an issue that happens with home appliance size freeze dryers, which some people might call boutique level freeze dryers. We're talking about the Harvest Rights, the Blue Alpines, the Stay Freshes of the world. Now, the reason that it's almost exclusively happening in these machines is because they run on what's called a pressure control philosophy. What does that mean? A pressure control philosophy? That means that the machine turns the heaters on and off depending on whether or not you're meeting that pressure target that's in the recipe that you pull up, that canned recipe that says fruit. It's 500 millitors your target pressure, and 125 degrees is your temperature limit. That's a process recipe for a typical small boutique size machine. So what is actually happening in there is, as the pressure in your chamber comes up to that 500 millitor, it's going to start cycling those heaters on and off to control the pressure in that chamber. Why is that? Isn't it the vacuum pump that's actually maintaining vacuum in your system? Well, no, it's actually not. Once the air is out of your system, all that's left in your chamber is water vapor. And if you have operated your system, you know that on the inside of your chamber you accumulate ice over the course of your freeze drying cycle. That's because your water vapor is ending up in the ice. If you hear somebody tell you that the water vapor is being pumped out by a vacuum pump, don't pay any attention, right? They don't really know what they're talking about. It's kind of absurd. Now, will the vacuum pump some water vapor? Well, yeah, because there's a little bit of pressure in the chamber, and the vacuum pump's pretty small, but it keeps pumping at that speed, so you'll get a little bit of water vapor out. And if you don't have the gas ballast on in your vacuum pump, of course, that's going to cause you problems in your vacuum pump. It's going to make you have troubles with your base pressure, and it's going to cause your vacuum pump to fail much sooner over time. But that's not really the issue here we're trying to get at. What we're trying to talk about is, why does one of them take a lot longer than the other? Well, if you remember, think about this, that you're in a pressure control philosophy. That means that the heater cycle on and off based on the total pressure that's in your chamber. If half of that pressure that's in your chamber is due to air, then only the other half is being used to cycle your heaters on and off. So if you have 500 millitor worth of, say, bandwidth to cycle those heaters on and off, then if it's all water vapor, then you get the full operation of your heaters. But if half of it, say 250 millitor, if the lowest you can get pressure in your chamber with your vacuum pump is 250 millitor, then half of your bandwidth is being used up by air. Your heaters are only going to be able to cycle on half of the time because it only can generate half of the water vapor to make up the rest of that pressure. So as a result, guess what? Your cycle time is longer. So it's really actually not really much of a mystery. It means that you have leaks. Now, can you have different level leaks between one freeze dryer and another? You better believe it. Every single vacuum chamber I've ever seen will have some leak rate. Now, the ones that are built for space simulation chambers, they have exceedingly low leak rates. In fact, outgassing of fingerprints that are stuck on the inside of the chamber exceeds what the actual leak rate is into the chamber from the atmosphere. But in systems that are being used for food, you're operating in a much different pressure range. You're not going to see any of those kind of effects. What you are going to see is difference in leak rates. Now, where do these leaks come from? Well, it comes from non-leak tight type construction. If you have threaded fittings that are being sealed up with Teflon tape, you got a leaker. It's as simple as that. I mean, using threaded fittings with Teflon tape is really at the tippy top of the list of things not to do among people who use vacuum systems. I mean, I know this. I mean, I was working in the vacuum, in the high vacuum, in the ultra high vacuum industry for decades. So I know quite a bit about this subject. If you are having issues with your freeze dryer taking too long or taking an inconsistent amount of time from one batch to the other, there are things you need to consider. And one of the first things you need to consider is finding those leaks. Could it be your vacuum pump? It can be, but I have to say, look, like I said, I did this for decades. I would get 1,000 customers who would call me and say, hey, my vacuum pump's not working right. What do you mean, sir? Well, I mean, it's not pumping as low in pressure as it used to, like last week or the week before. So it must be my vacuum pump. Well, is your vacuum pump still spinning, sir? Yes. Is it still have oil in it? Or if it's an oil-free pump, is it still spinning at the same speed? And if the answer is yes, then it's very likely still pumping. There are things that can harm the base pressure at which you can achieve in a oil-filled vacuum pump. One of those things is getting water condensing in your oil, right? If you operate your pump with a gas ballast open, you shouldn't have that problem. At least it shouldn't be a big problem. And if you don't know what I mean by that, I think I have a video that actually addresses that issue, or just reach out to me. I can help you with that as well. There's just a little knob on the top of your pump that you should see that has like maybe a 0 and a 1 or a 0, 1 and a 2. Put it in the 1 position. That means that you're bleeding a little bit of air into your pump. That will help sweep away that moisture so it doesn't accumulate in your pump, which will cause problems. If you have a leak, and this is the most likely cause, then you're going to have to find that leak in order to get your cycle time back into alignment. Now, look, if you are making product for a pantry, at home, who cares? Let it take 36 hours or 48 hours or whatever. Not that big of a deal. But if you're in production and you have contracts that you need to meet in order to stay in business, you best be taking care of this problem. You want your cycle time to be as short as possible so that you can pump out as much product as possible in the shortest amount of time. And remember, there's lots of other steps to do with your product. It's not just freeze drying. There's packaging. There's all kinds of stuff that you need to do. Shipping, you got to do the whole sales and purchase process. So you want to trim and optimize every single step of your business. You can't put this off. If you have vacuum problems, you got to find them and fix them. Is that easy to do? Not always. I've been exchanging text messages with a guy overseas who's got a machine that came from Utah, came new, but it's got some severe leak issues, and he's just having a dickens of a time finding the leak. We've been kind of trying to troubleshoot it by WhatsApp messages for quite some time now. The fact is that you may or not be able to easily find that leak. The most negligent OEM means original equipment manufacturer, in vacuum systems will fail to put a vacuum isolation valve between the pump and the chamber. If you are an OEM or you work for an OEM that makes any kind of vacuum system or freeze dryer and you don't have a isolation valve between the pump and the chamber, you should please listen to me and put one in there. If you are a user of a freeze dryer and you say have a Harvest Right or a Blue Alpine or a Stay Fresh or you name it, which kind, go get a ball valve, with hose barbs on both sides that fit properly into whatever tube size goes between your pump and your chamber. Cut that line, insert that valve, and put hose clamps on there. Because you need to be able to isolate the pump from the chamber to determine whether or not you have a leak. How do you do that? With your chamber dry, and this is sometimes the hard part. With your chamber dry, just pump down your chamber and shut that valve and see how fast your pressure comes up. It shouldn't come up very fast. That's one way that you can have an extended cycle. So are there any other ways? Yes, there are. Glad you asked. So think about this, right? So there's two sources of pressure in your chamber. We already covered that. One is air, which you pump out with a vacuum pump. Now let's assume you don't have leaks. The other one is water vapor, which comes from your product. Once it comes out of your product, it has to go somewhere, right? It goes into the ice, right? Whether that's on the inside surfaces of your cylindrical chamber, or it might be vertical ice plates or something along the sides or the back of your chamber. That water vapor is going into the ice. It's not going out through the vacuum pump. 99% of it is going into the ice. Well, if your water vapor is not going away, meaning your chamber pressure keeps getting higher and higher, and it's not due to leaks, then it has to be because your removal rate of your water vapor has declined. Why would it decline? Because your condensing plates are not getting cold enough. Why would that be happening? Well, because your refrigeration is either undersized or it's losing Freon, because once your refrigeration loses half of its Freon or whatever, it's the capacity at which it can remove heat is going to be reduced. If your refrigeration system is getting overheated, it's in a cabinet, it's in a room, it's in a hot room, it's going to affect the performance of that condenser and that compressor that's in your refrigeration system. It's going to make it take longer to pump out the same amount of heat. Okay, for those of you who are science geeks, and I hope I don't lose the rest of you, I'm going to talk about the vapor pressure chart just real quick. That's the pressure at which something becomes a vapor. Well, it's the pressure and the temperature, right? So this means that this is actually a chart of what temperature and pressure something will, let's call it, boil at. Although when you're less than 0 degrees C, you're in solid format, that's ice. So it's actually called sublimation, right? You remember, if you're in Denver, or say on the top of Mount Everest, the water boils at a lower temperature there because you're at a lower pressure. Well, if you put your stuff in a vacuum chamber, you can get actually much lower than atmospheric pressure, which means you can get much lower than freezing temperature. So if you're running your chamber at minus 30 degrees C, which is about minus 20 degrees Fahrenheit, look, your lowest pressure that you can possibly achieve is about 285 millitorr, same as micron. Micron millitorr, same thing. So you probably actually want to be more like at minus 35 C, so you can be at about 150 millitorr is your base pressure. Now I'm talking about base pressure. That's not necessarily your operating pressure, right? If you held your system with these temperatures and didn't have heat constantly putting more water vapor into your chamber, this is the pressure that your chamber would equalize out at, right? That's why at the end of your process, when you have very little water vapor left and the ice banks are governing the pressure, you come down to your base pressure, right? So if you can actually get to minus 40 on the surface, not on the surface of the steel, where the the condensers are, but the surface of the ice that's exposed to the chamber. If you could get that to minus 40°C, then you could effectively get your chamber pressure down to under 100 millitorr. And of course, you can't actually measure the temperature of the surface of the ice in there. You can only measure the temperature of the cylinder. So the fact is, I don't think most freeze dryers, even commercial freeze dryers, are necessarily going to hit minus 40 on the surface of that ice. Now, there's a difference between the temperature that your system can get to and what is called the capacity of the refrigeration system. The closer you get to its operating limit, where the temperature would be equivalent to the pressure, the lower the capacity, which is like the flow of heat, gets. The capacity, meaning how fast you can pump out that heat, is just as important, and maybe even more important in certain cases, than the temperature that it can reach. And it's not just the capacity of the refrigeration unit as written on the document, because that capacity is spec'd out for 0°C. I mean, I can get a refrigeration system that does, say, 10,000 BTUs per hour at 0°C, and it's going to do something like 50 BTUs per hour at minus 40 or minus 35. Okay, that's for pressure control philosophy. What else is there? Well, in commercial machines, it's almost always temperature control philosophy, and that's where the CPU, the PLC, that's in the computer that's controlling the system, it tries to maintain a particular shelf temperature. So it just turns the heaters on and off in order to maintain whatever temperature profile you've set in your program throughout that entire cycle. So it's a little bit more immune to things like vacuum leaks because it's not looking at pressure to control the heaters. So can vacuum leaks just be not a problem in temperature control philosophy machines? No, not at all. You can actually have vacuum leaks that are so bad that you can't keep your pressure from going so high that you start damaging your product. Just like in the harvest rights, say, or the Blue Alpines, you have a pressure control. You have a pressure control set point, but you have a temperature limit. In a temperature control philosophy, it's the opposite. We have a temperature control, but you have a pressure limit. So if it gets above that pressure, then your machine will automatically take corrective action. It'll turn off the heaters until your pressure comes back down. Okay, so yes, you can actually have bad effects in a commercial freeze dryer from vacuum leaks. It just takes longer for it to affect it enough for it to be a problem. The problem is, I mean, the real issue is with commercial freeze dryers that once you get to that area, you're going to take days or longer to find those vacuum leaks and get them fixed. And, a day of production in a commercial machine can be tens of thousands of dollars in lost production. So, you're at a different scale. So yes, vacuum leaks are actually a very important thing in commercial machines as well. Inadequate refrigeration is probably the worst cause of commercial machines going into what's called vacuum recovery mode, right, where it hits that upper limit and turns off the heaters automatically. Vacuum recovery mode, because your heaters are off, they're going to extend your cycle. And you could actually have some other problems that that happen in your product as well. Usually it's just an extension of the cycle, but that's usually almost always due to inadequate refrigeration. You got to make sure as an OEM or as a customer buying from an OEM that the refrigeration is spec'd properly. Now, I don't really have that much confidence in many of the freeze drying OEMs that they're all that good at calculating what size refrigeration they need just based on experience, but they should, right? But if you have a commercial machine that's going into vacuum recovery mode, you probably ought to, I don't know, give me a call and maybe we can talk about it. I'm sure we can get you further away from that so you stop having that issue. Okay, so, by the way, some people believe that to make freeze drying go faster, you just make the pressure lower. That's actually not it at all. All making the pressure lower does for you is it vaporizes your water at a lower temperature. It doesn't make it go faster. The only thing that actually controls how fast you have vaporization of water in your out of your product is how much heat you put in. Laws of physics, right? You have to put a very specific amount of heat in to a gram of ice to get that gram of ice to go into water vapor. That amount of heat is called the heat of sublimation, which is simply the sum of the heat of fusion, which is freezing, plus the heat of vaporization, which is boiling. So why do commercial machines use temperature control philosophy as opposed to pressure control philosophy? The big answer is for control. So you need more control over the entire process when you're in commercial production because you have quality standards and you have time production standards. You can't tweak pressure control machines very much. Sometimes you can have a hybrid between pressure and temperature control philosophy so that you can gain the best of both worlds. But for the most part, the reason that commercial machines are mostly temperature control is for all those reasons. It also gives you a lot of data that you can use to modify the system to understand where it's at, and also to provide certifications to agencies or customers that show that you either achieved or stayed below certain temperature thresholds all throughout the process. You can also optimize for production time and other things like that. So, the reason that commercial machines are almost all temperature control philosophy is because it is a superior method for the most part. Okay, so please, if you haven't already done so, give me a like. Also, subscribe to my channel if you haven't, so you can always be up to date when I release another video. And there are links in the description below for contacting me. Please reach out to me. I actually answer my phone. I answer emails. And there's some other links that are just convenient for you to use that link to products and that sort of thing. So that's all for this episode. I'll see you on the next one.